Today we are going to see some examples on a mathematical expectation. In the previous video we have seen what is the formula of a mathematical expectation of a random variable x. Okay, now we are going to apply that formula here and we are going to solve some examples on a mathematical expectation. See the first example. Obtain the expectation of a random variable x with the following probability distribution. What we have to do? We have to obtain expectation of random variable x with the following probability distribution. We should know the probability distribution of a random variable x. Then we can find out its expectation or its mean. So this is the probability distribution. Xi values are 1, 3, 5, 6 and these are their probabilities. Say the total of probability should be equal to 1 and here it is 1. So this is the probability distribution of x. Now the solution is like this. We have to find the expectation of random variable x, which is as follows. What we have to find, that we have written first. So we have to find the expectation of a random variable x, which is as follows. So according to the formula, we have prepared a table. We have prepared a table. Okay, so what we have done, we have written first column as xi, second column as pi. P of xi also we can write as a pi. And third column we have prepared as a xi into pi, because its summation we required here in finding out the expectation of a random variable x. So xi values were written 1, 3, 5, 6. Their probabilities were written. Now we have multiplied this. So 1 into 0.1, 0.1, 3 into 0.2, 0.6, 5 into 0.4, that is 2, 6 into 0.3, that is 1.8, and then we have add the columns. The second column total is always 1 because these are the probabilities, so total is 1, and we have made the total of this third column, that we get as a 4.5. And therefore here we have written expectation of x, that is equal to summation of xi into pi. So what we get, summation is total. The total of xi pi column we get as a 4.5. So we get expectation of x as a 4.5. Expectation of a random variable x or expected value of a random variable x or mean of random variable x, that is 4.5. And we can check ourselves whether our answer is correct or not. How we can check? We know that mean is a measure of a central tendency. Since it is a measure of a central tendency, it should occur at the center of the data. It should occur at the center of the data, not exactly at the center, but near to the center of the data we should get the answer. See our answer 4.5. Is it at the center of the data? Center of the data means our xi value, because this is a mean of x. So I have to see only the x values. What are the x values? 1, 3, 5, 6. They are not equidistant. But see the center. The center is in between 3 and 5. That will be 4. Our answer is near to 4. That is 4.5. So our answer is correct. Okay, like this we can check ourselves whether our answer is correct or not. How to check? It should be occur at the center of the data. That you have to remember. Second example now we are going to solve. What we have given in the example. Obtain the expected value of number of heads when 3 fair coins are tossed simultaneously. What we have to obtain? The expected value of number of heads when 3 fair coins are tossed simultaneously. So this is our experiment. We have written the solution like this. What is our experiment? That first we have written. Okay. What is our experiment? 3 fair coins are tossed simultaneously. That is our experiment. And we know what is the sample space for this experiment. When 3 fair coins are tossed simultaneously, the sample space is this. There are 8 sample points in this sample space. Since the coins are fair, so that's why the probability of each sample point is equal, and equal means that will be 1 by 8. So that we have written here. Since coins are fair, therefore probability of the first sample point, second sample point, third up to the last sample point, all that probabilities are equal, and that is 1 by 8. Okay, that is the meaning of a fair coin. Now whose expectation we have to find, that is our random variable x. Expected value of number of heads, that is our random variable x. So here we are written, let random variable x is equal to number of heads when 3 fair coins are tossed. So what are the number of here's the possible values. What are the possible values of x? 0, 1, 2, 3. Because how many number of heads are here? 0. In some sample points the number of heads are 1. In some sample points number of heads are 2. In some sample points number of heads are 3. Okay, so possible values of x are 0, 1, 2, 3, or we can say this is a range set of x. Okay. Now we are finding its expectation of x. For that I have prepared the table here. Xi values were written, Pi values, their probabilities were written, and then the third column we have constructed as Xi into Pi. What are our Xi values? 0, 1, 2, 3. What is the probability that x equal to 0? That means number of heads equal to 0. Number of heads equal to 0. That is only one sample point, that is t. So its probability is 1 by 8. Number of heads equal to 1. Number of heads equal to 1. There are 3 sample points. This one, and this one. So that's why its probability is 3 by 8. Number of heads are equal to 2. Here the number of heads are 2. Here also number of heads are 2. Here also number of heads are 2. So like this there are 3 sample points which contains 2 heads. So the probability, the total probability will be 3 by 8. Now number of heads are 3. Number of heads are 3. That is only one sample point, H. And its probability is 1 by 8. So like this, first we have written these probabilities. The total of the probability should be equal to 1. Okay. Now we have constructed this column, third column, multiplication of first and second column. 0 into 1 by 8, 0. 1 into 3 by 8, 3 by 8. 2 into 3 by 8, that is 6 by 8. 3 into 1 by 8, that is 3 by 8. And addition of this column is 12 by 8. So that's why our expectation of x or expected value of x is equal to summation xi pi. That means summation means total of that last column, and that is 12 by 8. 12 by 8 means 1.5. So expected value of a random variable x in this example is 1.5, or expectation of x is 1.5, or mean of x is 1.5. Like this, in any way we can say. We check whether our answer is correct or not. What do you think, whether our answer is correct or not? Yes, it is occurring at the center of the data. It is occurring at the center of the data means our answer is correct. So like this we can find out the expected value of a random variable x. But for that we should know what is the probability distribution of x. Okay. So like this you solve yourself some more examples on a expectation of a random variable x and make a practice of that. Okay. And you have to write down this also on a your notebook. Okay. And try itself, practice itself. Okay. So today we stop here. Further parts we will see in the next lecture. Thank you.